One of the things that sets clearly apart the C language, and therefore the C programmer, from its Java and C++ counterpart, well, essentially Java, since C++ also uses the pointer, is the usage of explicit manipulation of memory addresses. An explicit manipulation of memory addresses, as I already said, is achieved in the C language by a new data type of variable, namely pointers on something. So the same way that we can declare variables of data type integer, for example, okay, we have been using, integer data, for example, equal 42. We can define pointers on integer variable, pointers on double variables, and so on and so forth. So let's start by talking about the syntactical aspect first, and then we are going to illustrate exactly what those programs that we're going to write to play around with the idea of pointer mean, and we're going to do that by tracing their stack diagram. And then I'm going to start warning you about all sorts of things that can go wrong when you are using pointers carelessly. So let's start with the syntactical aspects, the easier stuff, okay? When I want to declare a variable of data type pointer on, let's say, int, okay, this is a syntax I would use. So let me finish this declaration here, and we're going to take a look at how to read it. Okay, ptr is a variable of type pointer on integer. You read it pretty much right to left. Okay, ptr is a variable of type pointer. This is what the star symbol means here in this context. Pointer on integer. Okay, quick little remark here before we go even any further. If you have several of those variables to define, ptr1, ptr2, this is what you need to avoid. Okay, you need to avoid assuming that just the same way that you can have int x, y, z on the same line, declared all of them as integer. Try not to fall for the trap of believing that ptr1, ptr2, and ptr3 in this case are going to be pointers on integer. Okay, it's even worse when you see programmers writing things like that, because then it really looks like ptr3, ptr2, and ptr1 are all what? Pointer on int. Well, they're not. That's why I put a space here and no space there, to remind myself that if I want ptr1 to be a pointer on int, I need to indicate that ptr1 is a pointer. If I want ptr2 to be an int, this is perfect. But if I want it to be a pointer on int, I need to add a star here. Okay? And something for ptr3. So if I want those three variables to be all of them pointers on integer, I cannot simply write, pointer on int one time here, and then list ptr1, ptr2, ptr3. Nope, I will have to put the base primitive data type int here, and then remember for each of my variable declaration to put an asterisk, a star symbol, to notify that I want them to be a pointer on whatever the data type here is, in this case int. Okay, you saw also sooner that I was initializing my pointer to null. It's a good idea to do it all the time. Okay, every time you declare a new pointer, initialize it to null. So there are plenty of situations where it's not indispensable, it's not mandatory, but most of the time it's a good programming practice to take, especially when you are just starting playing with pointers. Okay, the null value is something that is defined in the standard library of the C language to be pretty much the equivalent of a zero value, but a zero which data type is not int or double or long or whatever, a zero which data type is pretty much a memory address. So that represents the memory address 0. Why do we initialize pointers to null? Well, very simple. When you use a pointer, you use an operator called dereference. Okay, which means pretty much and unfortunately the syntax for dereference is again using the star symbol, which makes it really confusing, because when you see a star in a declaration, that means I'm declaring a pointer. When you see a star in an expression which is not a declaration, that means I am pretty much dereferencing a pointer. So you would use it like so, okay, star followed by an expression which results in a memory address. So typically the pointer ptr1 contains a memory address. So star ptr1 means dereference to the memory address contained in ptr1. And what that does for you, it allows you to manipulate whatever is located as the memory address you are dereferencing. For instance, star ptr1 equal 42. Let's take a break here. Okay, let's take a quick pause, and let's just do a diagram of what's happening in memory for this simple program before we run it even. Okay, and you're going to see why I don't want to run it just about right now. Okay, I want you to understand exactly what's happening with the declaration of pointers and the dereference of pointers before we go any further and start, warning you about bugs and things like that. So here's what we have so far on our program execution stack. Okay, text segment is over here, data BSS segment is over here. We have a local variable data which contains value 42. We have x, y, and z which contain no value at the time, and then we have ptr1, ptr2, ptr3, which are the three pointers which we assigned to null. Okay, so this is our starting state, and we are going to now explain what happens with those pointers and those dereference operator based on this starting state.